And now we have to understand what exactly is resistance, because last time I said we'll quickly talk about resistances, and once we talk about resistances we will have a few things in down our sleeves and we can actually work out with some problems. Okay, so if you're ready, please make sure you have a copy with you all so that you can actually work out some examples. All right. Okay, so quickly, resistance is in series and parallel. What is a resistance? You all know, something that resists the flow of current. So quickly, just to mention what exactly is resistance, so I'll quickly give you an illustration so that you understand. Let's say this is PB Road. All of you have been to PB. For some of you who are not from this state, maybe you are in a marketplace and then there's lots and lots of crowd. Let's imagine that this crowd, and it's not the corona time, so everyone is walking around freely, and then they are actually very happy about walking down the street, and then suddenly you are also walking along. Okay, this is you, and then you walk and you want to walk a bit fast, but suddenly when you reach this point A, you encounter this group of people, and then you understand that you will have to walk slow, right? You will have to slow. Obviously, previously we were walking a bit faster, but right now you have to walk slow. And the reason that you have to walk slow is because of the fact that these people are actually blocking your road. So resistance is also very similar. Resistance is this group of people who are blocking the road for current. So this is a very, very short analogy of current versus resistance. So this is the resistance. I think it's pretty clear. Another example can be something from if you have ever been to a river. When you walk in the river, it's quite difficult to walk, right? Because of the resistance that the water is giving. Resistance given by the river will actually slow you down. You cannot run like the way you'll be running out of water, and even if you walk in water, you have to walk slowly. So that is the resistance. I hope that clears the doubt about resistance. Okay, so now what is resistance? So I hope you can actually see it. If not, I'll just erase this part. Okay, so what is actually resistance? Resistance is nothing but it resists the flow of current. So how are resistance connected? So I'll quickly go to that. How is it? So when two or more elements are in series, all right, this is when I'm talking about resistance in series. So resistance in series, what exactly is that? When two or more elements are connected in series, they are said to be in series if they are cascaded or connected sequentially and consequently carry the same current. So let me just draw that. What do you mean by that? So let's say I have one resistor here A, resistor B, and resistor C, D, and so on and so forth. So R1, R2, R3, they are connected sequentially, right? One after the other. And from one end to the other end, so one resistance is connected to the first end of the resistance, say A is connected to point B, is connected to point C, and D, and E, and so on. It goes on. This is when resistance are connected. And if you connect a battery around here, you find that the current which is flowing through the circuit is actually the same current. R1 will have the same current like R2, R3, and R4. So that is meant by resistance in series. Okay, so this is the formula. Rs is equal to R1 plus R2. Someone is trying to get in. Let me just quickly let them in. What is resistance? Two or more elements are in series if they are cascaded or connected sequentially and consequently carry the same current. So this is what I have drawn here. And once you have this is actually resistances in series. So this is the formula. Rs equal to R1 plus R2. If you have 3 resistance, then it will be R1 plus R2 plus R3. If you have 4, then it will be R1 plus R2 plus R3 plus R4. So that is what we have here. And now we can quickly, if there are n resistances, then what we'll have, you'll have R1 plus R2 plus R3 plus R4 plus R5 plus R6 plus R7 plus R8 plus R9 till Rn. So that is your resistance in series. I hope it's clear, right? So we'll quickly move on to resistance in parallel. What is resistance in parallel? Resistance in parallel, I just give the sign there because that is the sign we actually use for parallel. Resistance in parallel means what? Two or more elements are in parallel if they are connected to the same node and consequently have the same voltage across them. What do I mean by that? Say I have a power source here, right? And then I have a resistance around. If you here, this is a node, this is also a node. So two resistance, say R1 and say R2, will be said to be in parallel, will be seen if connected same node. See, look, this node and this node are connected together, right? The node of this resistance and this is the same. And if you look at this, the voltage across this, across R1 will be 5 volt, across R2 across R2 also will be 5 volt. If you measure the voltage across R1 and across R2, in both cases you will find that they are 5 volts. Okay, so that is what you mean by connected to the same node and have the same voltage across them. I hope it's clear. So now if two resistances are in parallel, that is R1, R2, so the total resistance will be what? I can write down here. So if two resistances are in parallel, R1 and R2 are in parallel, so if R1 and R2 are in parallel, so I'll have to write down 1 by R1 plus 1 by R2, right? You all have done this in class 12. This is parallel resistance. So this is nothing but, if you take the LCM, it will be R1, R2, and then you have R1 plus R2. So if you take the reciprocal, Rp will be nothing but R1, R2 divided by R1 plus R2. So that is what we have here. 1P is nothing but 1 by R1 plus 1 by R2, and Rp is nothing but R1, R2 divided by R1 plus R2. I hope it's clear, right? And if you have n resistances, then please look here. So if you have n resistances, then it will be R1 by Rp, it will be R1, 1 by R1, R2, R3 plus little 1 by R. And then you have to take the LCM. LCM be R1, R2, Rn. Then the first term will have R2, except for R1, all terms will be there, right? The second term, except for second term, all will be there. The third term, all the terms will be there except third term, and so on till Rn minus 1, right? And then finally, you will have Rp to be given by R1, R2, Rp10 divided by this terms that you have done earlier. So it's very straightforward, right? I'll just quickly show you three resistances so that you have understanding of to what exactly I was talking about. So quickly, I'll just go back here. I'll write down, if you have R1 parallel R2 parallel R3, what do you have to do? You have to write down like this, right? R1 plus 1 by R2 plus 1 by R3, right? So this is, what is the LCM for this one? It'll be R1, R2, R3, right? Till Rn. So the first term will have just R2, R3. Second term will have just R1, R3. And the third term will have R1, R2. And finally, if you take the reciprocal, your resistance is your total resistance in parallel will be given by R1, R2, R3 divided by R2, R3 plus R1, R3 plus R1, R2. So that is resistance in parallel. I think it's very, very clear, right? Okay, this is assignment for you all, so you can quickly I will quickly stop the screen, the slideshow for time being. I want you to do something for me. All right, I want you to actually quickly move on and take your copies in your hands, and then I'll give you a small assignment. If I have two resistances, just listen carefully. If I have three resistances, if I have three resistances, R1, R2, R1 is equal to 5, R2 is equal to 10. What is the resistances in series and what is the resistance in parallel? R1 is equal to, okay, now we move on next to the next part. We have seen what is resistance in parallel, and we have seen how we actually can calculate, and now we can go to quickly, first of all we go to power, but since I have forgot to put any animation here, we'll quickly understand what is a short circuit and what is an open circuit. Short circuit is when the resistance is 0. resistance is approaching 0, short. An open circuit is resistance is approaching infinity. So when the resistance is very, very large, it's an open circuit. And when the resistance is small, very, very small or approaching 0, the resistance is called, or the circuit is called short. So let me quickly draw what's a short. So if I have a circuit like this, and if I join these 2 points, say this is a circuit. So if I join point A and B, if I join using a wire, that is a short. If I join point C and D, again using a wire, it's a short. Now please remember, a short is a part of least resistance. So if current starts flowing here, okay, let me just ask you, which part will it flow? Will it flow through CA or will it flow through CD? If current flows in the circuit, it will flow through CD. Again, yes, you're right, through CD. Again, you can take the analogy of you walking in a very crowded road. Will you always try to push through the crowd, or you will always like a road which is free? Always a road which is very free, right? So the same way, the current also will not light a road with resistance, a road without resistance. So if I have this short, the current will flow through this part. Please remember that, don't forget it, okay? And if I have this circuit, just look here. If I have this circuit and I have nothing here, all right, see, there's a resist here. But if I have nothing here, this is called an open circuit. If I remove, if the resistance is almost equal to infinite, because if it's open, that means the resistance is very large. Current can never flow from this point to the next point, right? Even if actually quite high, it can never flow. Of course, there are some exceptions, but in the end, current will never be able to flow if it's an open circuit. So that is an open circuit resistance, and since it's connected to resistance, so I will actually continue with that. Okay, I hope it's clear. Now we'll quickly go we'll go to power. Power, what is power? Power is nothing but the time rate of expending or absorbing energy, measured in watts, or the rate of doing work is known as power. The rate of doing work is known as power. The P is equal to W by T. But we know that V is nothing but W by Q. It comes from the definition of potential, right? Work done per unit charge, that is the definition of potential. So that will be giving you W is equal to V into Q. And here we have, if you substitute this value back here, you'll have P is equal to V into Q divided by T. And Q by T is actually nothing but the definition of current. We have done this also. Therefore, P is equal to V into I, right? Therefore, P is equal to I. But V is nothing but IR, right? V is not from Ohm's law. V is equal to IR. So you substitute V is equal to IR here. It will give power equal to IR to I. It will actually give you I square R, right? Again, from Ohm's law, we have V. I'll just write it up here. Again, from Ohm's law, we have V is equal to IR is equal to IR, right? And from here, we have V by R is equal to I. So if you have power V into I, if you put down, instead of I, you put down V by R, you'll get V into V by R. This will give you V squared by R. So these two, this one and this are two formulas for. So we have three formulas: V into I, which is equal to I square R, which is equal to V squared by R. So all these three are formulas for power. Is it clear? I hope it's clear, right? I hope it's clear. Okay, so this is what I have in mind to do with you all today. Next class, we'll start from the definition of, we start with problems from power. Okay, so if you have any questions, you can quickly share. I'm going to quickly go and look at voltage divider and current divider. So what are these? We'll quickly understand it in a few moments from now. So once you have learned Ohm's law, now as I've said earlier, Ohm's law will be the basic Ohm's law, which is nothing but V IR, and we can actually transpose and do the needful to do some cross multiplication, and we can also get the R, we can also get I from the same formula, right? So basically this will be the basis of us calculating the various formulas for voltage divider and current also. But as some of you have already done most of the things, we'll quickly look at it very fast. Okay, will not be very slow. We'll just quickly jump into voltage divider now. Now, what is a voltage divider? If you look in here, if we have three resistances in series, right? If I have three resistances in series, let's say we have three resistances in series. So let me draw it. So we have voltage source and we have three resistances in R. Let's say R1, R2, and R3. This is so. What will be the current through this? Now you know in a series circuit the current will be in just one. Just hang on, someone is entering. Alright, so this is what we have. So that's the current. So I is equal to V divided by R1 plus R2 plus R3, right? So now my question is, what is the voltage drop? Say let me call V1 here. What is the voltage drop across R1 here? What is V1? Now if I look at this, what is V1? Voltage was, let's say, okay, let's take the voltage 3, R3 here. So let me call this V3. The voltage drop across V3, because R3 is nothing but, we can get it from here. I is equal to V divided by R1 plus R2 by R2 into R3. Actually this is into R3 into R, where R is equal to R3. Okay, so I'm going to write it again because I've just wrongly written it here. So I is nothing but, oh, sorry, this is okay. Sorry, let me just restart what I said. Just redo what I said. So that the others also gets some. All right, okay. Here I is given by V divided by the series combination of R1, R2 and R3. So V R1 plus R2 plus R3, that is Ohm's law, right? V divided by I, V divided by R, sorry. Now if you are asked to find out the voltage drop across R3, this resistance R3, let me call that V3, R3, what you need to do is you need to simply use Ohm's law, V is equal to IR. So what is I? I is nothing but V, I is equal to V divided by R1 plus R2 plus R3. And what is R? R is equal to R3, right? So you substitute V out there, you'll get V3. You'll get V3 given by V3, which is nothing but the voltage drop across, which is the voltage drop across R3, will be given by V divided by R1 plus R2 plus 3 into R3. So that is a voltage divider. Let me take a simpler one. Okay, let me take a simpler one. Let me take this this one here. Just quickly. Okay, let me just quickly take this. Let's see. Most of the voltage dividers will be something like this. Let me call this 5 volts. This is R1. This is R2. So from here, what we need to do first is find out the current. So current is nothing but I equal to 5 or V divided by R1 plus R2, and then you get what is the voltage drop versus R1. Let me call this V1. So V1 is nothing but I into R, and in this case I is equal to IR1. So this is nothing but 5 divided by R1 plus R2 into R1. Similarly for V2, you just need to replace, for V2 here you just need to replace R1 by R2. So that's the whole idea. So this is actually you'll get this for the first circuit that I've drawn earlier. This is R2, voltage drop across R2, and voltage drop across R1. And if you look at it, let's just quickly look at some problems before we move on to the next topic. So let me just take a problem here. Let me say that this is 10 volts, okay, and then we do say 5 volts and 5 ohms and 5 ohms, they are equal. Okay, so let me write down, mark some points, say A, B and C, right? So I need to find out VAB and I need to find out VBC. So First of all, I need to find out I. Right, I for the second. I is nothing but 10 divided by V divided by R1 plus R2, right? Which is nothing but 10 divided by 10, which is nothing but 1 amperes. If this is ohm and this is in volts, this I is the 1 amperes. Therefore, VAB nothing but I into R1. In this case, R1 is nothing but 5, right? So it will be I, which is 1 amperes into 5 is equal to 5 volts. Okay. Similarly, VBC is also I into R2 with nothing but 1 into 5, which is equal to 5 volts. This is a case when both. Let's take another case here. So in the first case, we have both voltage drops to be equal. Let's take another case. Let's say that this is actually your differential divider circuit. This is again 10 volts to make the calculation easier. And let me say that this is 3 ohms and this is 2 ohms. Let me see what is the current. So current I is nothing but 10 divided by 3 plus 2, which is nothing but 10 divided by 5, which is 2 amperes, right? Now this is 2 amperes, that is the current, and now we need to find out what is VAB and what is VBC. So what is VAB? VAB is nothing but equal to I into R1 RAB. So RAB is nothing but 3 ohms, which is nothing but 2 into 3, which is nothing but 6 volts. Okay. So and VBC is nothing but I into 2, which is 2 into 2, again is 3 volts. Now please note, if you add VAB and VBC, again you get back the source voltage. Please note that VAB plus VBC is nothing but 6 plus 4. You get back the source voltage, right? 10 volts. Similarly here, you'll get back 5 volts plus 5 volts. So this is 10 volts, which is the source. The DC source that we've applied here, right? Okay, so now we take a bigger problem. Let me look at one such problem. Let's just take a look at what's. Let me call simple article. That's the. Let me. This has 20 volts. This is 10 ohms. This is 6 ohms, and this is 4 ohms. 10 ohms, 6 ohms. Okay. Now, what is current? First, current is nothing but 20 divided by 10 plus 6, which is again t divided by 20, 3 here. So let me mark this point as A, B, C, D. So what is VAB? VAB, or what is the voltage drop? The resistance 10 ohm. Resistance 10 ohm. Resistance 10 ohm. Right? So that will be equal to current. V is equal to IR. So I is what? Into 10. This is equal to 10 volts. What is VBC? This is nothing but again current into resistance 6, which is equal to 2 volts. And finally, what is VCD? Nothing but current again into resistance 4. Again, if you add up, you get 20 volts, which is again the source voltage that we are getting. So I think it's very clear, and it's very easy for you to actually find out what is the using this for. You can use this this potential dividers formula to get the voltage drop across any resistance for that matter. I think it's very clear, right? Okay, now we move on to the next part, current divider. What is a current divider? Now, as I've said earlier, in a series circuit, the current does not divide. The current flow is the same throughout the circuit. Let me just quickly, and then if you look at the current at the parallel circuit, the current always divides. So we look at it. Okay, so this is actually if you remember clearly, this diagram here was given to you when I was doing KVL. Now if you look here, this is a parallel path. See, 8 amperes gets split into 5 amperes and 3 amperes, right? So this is what I'm talking about. If you have a parallel path, it need not necessarily be parallel. When you say parallel, you sometimes visualize this as a parallel path sometimes, right? Sometimes, so not necessarily like that. Parallel path can be always, it can also be something like that. If you look at it, so these three are in parallel right now, right? And if you do this and do this also parallel, since both ends of the circuit of the resistance are connected to the same ends of the other resistances. And similarly, if you have this kind of circuit, again here you have parallel. So this resistances will be in series with the parallel of R2 and R3. Again, I'm repeating. If you look at figure 3, the last figure that I've drawn, if you consider this as R1, this as R2, and this is R3, so R1 will be in series with R2 parallel R3. If I do something like that, right? Complete the diagram like that. So now you understand what do you mean the parallel circuit. So in such a case, in this circuit here, which is given here, you can see that if current flows from here, let's say that I have voltage source, and if current starts once it reaches point, it will start dividing themselves into two portions, right? One flowing through R2 and the other one flowing through R3. So that's why you have to understand current divider circuit. So let us see and quickly look what is a current divider circuit. So let me just quickly bring in, if there are two resistances in parallel, the figure, let's say I will draw it here. Let's say if I have two resistors in parallel, there is R1, there is 2, R1, 2. So current will be divided. Say this is voltage and one current comes there, it divides, right? It divides itself. When it divides itself, right? So it will not be a similar case that we did earlier in potential divider. But now, for finding out the current flow through R1 and the current flow through R2, we need to do something extra. But first of all, we need to find out the main current IC. So let me find out the main current IC. What is IC? IC is nothing but voltage divided by resistances here are in parallel, so it will be R1 parallel R2, right? Which is given here. This is the main current IC. Once you get the main current, you can find out what is I1 and what is I2. Let me call this I1. Let me call the other one I2. So once you know what is IC, you can find out I1 and I2. How? By using these formulas. Okay. So this is actually the circuit which was meant to come here. So this is the circuit which I have drawn. Once we find IC, we can find the current through R1 and R2 by simply using the current divider formula, which is nothing but this. So current through R2 is nothing but IC into R1 divided by R1 plus R2. And current through R1 is nothing but IC into R2 divided by R1 plus R2. So kindly note these two formulas. They will be very, very handy when we will be solving your theorems later on. So that is the current divider law. So we'll quickly look at examples to understand this law further. Okay. Let me take an example here. Let me use first 10 volts. Let me then bring in equal inside 5 volts, and let's call this I1. Let's call this I2. In this case, for sure, you know, since the resistances are equal, for sure they will be equal. Okay, the current also should be equal. So equal current will be flowing through 5 ohms, through both the 5 ohms resistances as shown here. So, but before that, we calculate IC. This IC. IC is nothing but 10 volts divided by 5 parallel 5. And if you calculate 5 parallel 5, what is 5 parallel 5? 5 into 5 divided by 10, so it's 2.5. So 10 by 5 into 5 divided by 10. So basically this is nothing but 4. So this is your IC, 4 amperes. And once you get IC, what is I1? I1 is equal to, according to formula, I1 is nothing but IC into R divided by R1, where R is this resistances. This is R2 and this is R1. Okay, so this is nothing but 4 into R2 is 5 divided by 5 plus 5. So what you'll find here is nothing but how much? 4 5 is 20 divided by 10. So basically it's nothing but 2 amperes. And similarly, I2 you can find out IC into R2 divided by R1 divided by R1 R2 plus R2 is nothing but 4 into 5 divided by 5 plus 5, which is nothing but T again divided by 10 is 2. So as I've said earlier, both these I1 and I2 will be equal. Okay, this is the first problem. Let's take a similar problem, but now let's change these resistances. 5 ohms and 5 ohms. Let's change it to another one. So let me put in another resistance. Okay, let me just use this in here. So let me take this as 10 ohms, and let me take this as 4 ohms, and let me take the voltage in 20 volts. So first of all, first step is find out IC. IC is nothing but 20 10 parallel 5, right? So this is nothing but 20. 10 parallel 5 is 5 into 10 is a 50. 50 divided by 15, so approximately it will be 5 3 is a 15, 5 10 is a 50, so basically it will be 6, right? 6 amperes. Okay, so this is the main current, and once you get the main current, you can quickly calculate what is I1. Let me call this one. So this current flowing through 10 ohms is I1, and current flowing through 5 ohms is I2. So what is I1? I1 is nothing but equal to main current 6 into the other resistances R2, which is 5, 10 plus 5, right? It's nothing but 6 into is 30 by 15. This is 22 amperes, and I2 is nothing but 6 into 10 divided by 10 plus 5. Again, this is 60 divided by 15, and this is 4 amperes. So clearly you see that I2 is actually greater than I1, and all of you know why, right? Do you know why? Why is I2 greater than I1? This is a question for you all, so kindly take note of that. Why is I2 greater than I1? So this current divider law. So for today we stop here. Thank you so much, and if you have any questions, we can further proceed with the class. So please note this question: why is I2 greater than I1? Okay, so now we can stop for today, and you can actually ask any questions if you want to, and if you don't want to, we can actually stop the class right now. And you can actually ask any questions if you want to, and if you don't want to, we can actually stop the class right now.